So I'm really happy here, like actually to introduce our optimization for LLM, and actually also this also apply to the computer vision and a lot of different deep learning pipeline there. And feel free to type any question because first of all, I will go through the why we do it and why we use Alluxio as a distributed cache, and at the same time to serving this kind of LLM data pipeline and the computer vision pipeline, and then we will go to detail about the technical implementation of the work. Okay, this is mine, and I already introduced myself. And first of all, let's give some introduction. What is Alluxio in case some of you not know Alluxio before? Actually, Alluxio is a project initially actually it's open source from the UC Berkeley M Lab. And nowadays we already have more than thousands of the contributors in our community. And we also recognized by the Google top 10 most critical Java-based open source project. And last year, we also recognized by the IEEE to win the first open source award for the IEEE. Actually, since actually we have very long journey in the past, actually, not only for the deep learning and machine learning, we also integrate with the Presto, integrate with the Hadoop ecosystem, and also integrate with the Spark. So actually, you can think about like where the middle layer, I would not say the caching, but actually basically the middle layer of between the computing framework and the storage to provide the tremendous of the benefit to you, not only the performance, but also together with the API cost saving for your cloud storage, and at the same time help you to manage the data with a single entry point from Alluxio. This is the company are using Alluxio, and many of them are running us with the model training and the model inference, and at the same time with the data analytics. So now it's the most exciting part why we really want to use Alluxio to solve your I/O challenges in machine learning and deep learning. Actually, as we said before, actually, I would give some basic introduction in case you don't know what is exactly machine learning pipeline looks in our view. Actually, first of all, actually, the two very important part for the machine learning deep learning is one is definitely the model training. You will put your training or label the data into your model. It can be the already pre-trained model or even untrained model. Then you will generate the trained model to serve your business requirement. Another part is really about your inference. Inference means like you have unknown data from the user or internal team or whatever you get the data source from, and put into the trained model cluster, and it will generate a predict or the response to you from this pipeline. The one example is really when you use the ChatGPT, you input your like question there, and actually it will go through their inference cluster and generate the output to you. Then you get the answer. But actually, we are not at in front of the user, but we are really help you to optimize the machine learning and the deep learning pipeline. So what kind of challenge actually we see here is I list here. The first of is metadata scalability. There's one that there is like people say like I always can do a lot of pre-processing and to extract the feature from my raw data into my system or feature store. But actually, what we saw there is like people usually like would like to extract the most of the information from your raw data, which cause a problem is like in practical, like we saw in the different company, it's easily to achieve 10 billion of the scale there. So which means like if you really want to get a very good model with very high accuracy, you need a large amount of raw data from your system, especially actually this kind of is unstructured data. You have want to extract the benefit from there. So we saw like for the computer vision or for the NLP even, like before the pre-processing, you can even have like billions of the 100 KB like photos or some for the sentence you extract from there. The second problem is like, now the GPU availability is a big issue for many different companies. So people go to the cloud to extract utilize the GPU there. But the problem is when previously you are in the on-premise environment or you are in the your own IDC, actually you just buy the hardware and then you utilize no matter it's the high performance computing storage or you using the traditional like storage or use the object store to serve your data. It's only charged for you the hardware cost. But when you move to a cloud, they have totally different pricing model. They will charge you for both for the storage and the how many requests you request from the cloud storage. Actually, you will see tremendous growth once you move from the on-premise to the cloud environment. The third part is really about the technical burden there. Like for this kind of training, if you're training with a single GPU, you have to wait infinite time to get your trained model. But actually nowadays, like the freshness of the model is more and more important. People really want to train with the large scale of the GPU cluster. What we saw, it can be the hundreds of the GPU nodes. Each node can be eight like GPUs there. So actually it causes a very high burden to the underlayer system to say like, I even cannot serve this kind of IO throughput to our machine learning training and the deep learning training or the LLM. Okay, so this is the basic idea why you really want to use Alluxio for the deep learning. Just think about it, like actually you have various of data source. I will go in detail about it, why this happened afterward. But you have to get the data from this data source, and actually it can be from object store, it can be from the traditional like storage system, it can be anywhere like in your like data source, and you are porting to Alluxio. And on the top of Alluxio, we provide the fuse with the POSIX interface to serve your deep learning training. So actually, just think about it. Previously, if you want to do it, you need to copy the data from the data source to your local, or copy the data from the source to your like intermediate storage system like raster or like other system to serving the data. But nowadays, you don't need to worry about it. You don't need to do the data migration. We will do the intelligent like data set concept for you to move the data from the object store to the Alluxio and serve the training data. And the second is really about cost. Even design the system at the beginning, we're thinking about even we really want to implement like the link or even like RDMA, this kind of technology for the customer. But we realize actually this kind of hardware is super expensive. And at the same time, actually it's provide too many IO throughput there with no reason. Actually, we are using a cheaper like in general machine, like every EC2 can deploy Alluxio and provide very good performance on top of it. And the third part is like we also leverage the Kubernetes technology, like we make the idea of, for example, for the machine learning training or deep learning training, you have set of the language library there for the data set. We will package this and serve to you directly from the Kubernetes concept. Yeah, next time I will go through detail why really people want to do training with Alluxio and the reason behind before actually we illustrated there. The first of all, when the first day people building the data warehouse, actually at that time, people never think about like 10 years later, people really also want to build the AI platform infrastructure on top of that. So if you look into the existing data lake or data warehouse architecture, you usually see like under layer, it will be the Hadoop HDFS or the like cloud storage. And on top of it, you have Hive to serve the metastore. And then on top of it, you have like Spark or Presto, all this kind of computing framework to do the job for your ETL, do the job for your ad hoc, and do also data clean for your data warehouse. But at the same time, when the machine learning and the deep learning for LLM become very popular, people realize actually from hardware-wise, we used to always run the CPU with the Spark Presto and all this kind of computing framework. But for the GPU, actually it's for the PyTorch and TensorFlow. And the secondary is in this kind of data warehouse, your data always like, I would say structured or the semi-structured. It's not really like unstructured data there. But for the deep learning, actually it's always have a lot of unstructured data there. And third is really about the tech stack differentiation. If you think about like I run with the Presto, Spark, Trino, this kind of framework, usually like I would say 90% of people, the only requirement will be the SQL. So which means like if you write a SQL, then you can do all the work for there. But for the deep learning world is very different. Like people usually write a Python code like NumPy, Pandas, all this kind of library to do the training. And based on all this kind of about reason, like people usually separate the data warehouse and AI infrastructure in their organization chart. So it's also caused some problem there. First of all, it's like, although you want to do the training, you have the infrastructure, you have the tech stack, you have a computing framework there, but you still want to maximum to utilize your data from your data warehouse. So you need a connection between the data warehouse data to the training infrastructure. But the big problem here is like the one way you want to do it is like you can build the storage system there. But what we saw there is like if you build a storage system there, like persistent storage system, which means like you always have to copy the data from the data warehouse team or the data lake team to the AI infrastructure team. Copy data is easy, but actually finally you will realize actually people rarely not maintain it, and you will keep every copy in your cluster. And we saw many examples already. You have the full copy of data in your data lake or data warehouse, then you have a half copy of the AI infrastructure like a team. Actually, it's cause a lot of cost problem, not only even for the API cost, but also for the storage cost for your team. And the secondary is about the performance. When you direct access the data from the, for example, you access the data from the S3 or the HDFS, actually this system is not designed for the AI and like no matter large language model or the deep learning model IO pattern. It's really designed for the traditional data warehouse, which means like you have a large block there, like 64 megabytes is minimum. It can be 1 gigabyte per block. But for the file, if we mentioned before, it usually can have 100 KB files, billion of 100 KB of files there, and you have to consume this kind of data. This is a problem for the training. And the second problem is really for the inference. For the inference, it's really depend on scale. If your company at a very early stage, if even you run the inference with several nodes, it still can satisfy your requirement. You don't need to worry about it, and you just consume the data from the S3 or the HDFS for inference to onboarding the model to your cluster. But imagine like you have relatively large business there, and you have to serve like millions of even billions of users in your platform. So for that time, for your inference cluster, usually can be very large. It can be thousands of nodes, even only for one data pipeline. One example is really like if you think about ChatGPT, they have like thousands of tens of thousands of the inference cluster there. But when you want to onboard in your model into this inference cluster, if you direct consume from the S3 and HDFS, it will have very severe throttling there. So actually, you still need to have a very good way to ensure the high concurrency there from the storage system to your inference cluster. Okay, so this is the problem actually we are solving at this moment. First of all, like if you talk about existing solution, actually compared to the data migration, you put the cloud storage and another like a raster and MinIO or Ceph, all this kind of object store in the middle to do the thing. But you will realize, like, for example, for the raster, this kind of system is very expensive. It require you have the RDMA. It require you have to have always to use NVMe, and very high performance like node to serve your request. The second problem is like if you really want to integrate with data migration, just imagine you want to onboarding one model called the ResNet 15, and you also want to onboarding another like LLM like model into your cluster. You have to create this kind of data migration pipeline each time for your new model, because not only you have to move the data from the data warehouse data lake, and at the same time you also have to do the error prone. You also have to ensure actually there's no problem there. And the third problem is actually you also have to delete all data in the persist layer, no matter you are using cloud storage or the HDFS. Otherwise, it will have an incredible like billing to your department. And third, actually, it's more important. Actually, it's really reduce the efficiency for the data scientist. They have to understand what's the difference between the data source and the AI machine learning infrastructure. They have to launch a data migration, and at the same time, they have to wait for it. The second, actually, it's compared to direct access. If you direct access, for example, if you take the Azure Blob as an example, we used to cooperate with the Microsoft team. They directly training their PyTorch, a model with their PyTorch on top of the Azure Blob. Actually, because actually cloud storage, in order to achieve the fairness for each of the user, they do the throttling for your metadata operation at the same time for your data operation. So you will see the GPU utilization is relatively low there. It will be like 20% to 30% for the majority of the large language model training, and also for the computer vision training. So just give one pricing example here. Is like if you check on the AWS, the recent A100 node, actually, if you are not the big customer there and you are not rent a GPU for the whole year, the on-demand price is $40 per hour for a single node. If you only can use 20% or 30% of the utilization, which means no matter you want to buy more GPU machine to serve your machine learning pipeline, or you have to wait for a long time. So actually, it's kind of like if you calculate every month, if you increase from the 20% GPU utilization to the 80% of GPU utilization, you can save around more than $15,000 per month. And the second problem actually is exactly what we see for the large language model training and for the CV. Cloud storage API is like insane in this kind of scenario. Just imagine in the traditional data analytic environment, the hot data, if you can access 50 times a day, it's already very hot data. But in this machine learning training pipeline, it's ridiculous. It can be easily achieved 10,000 times per training for the same copy of data access. So which means like it's easy. You can see like thousands of the dollars cost on the API for your model training if you directly access the cloud storage. And the third problem is actually it's really about coupled architecture. If you have your data there in the one cloud, actually it's very hard for you to consume use another GPU from other cloud vendor to consume this kind of copy of data. Actually, we will help you on that. Okay, and I want to give some ideas of how we really solve this problem in the technical perspective. If you recall at the beginning, we say like scalability always very important. Just imagine you only have one data set with 10,000 or 10 million of the file with the image in your system, or 10,000 of the with maybe only like 10 gigabytes of data for NLP training. You cannot say very good accuracy there. The size of data is the magic for the deep learning training. So you always want to have more and more data in your training system to make sure it's possible for you to achieve very high accuracy for your model. So actually, nowadays, like we do the redesign and we introduce the new architecture called the DORA in Alluxio system to make sure we can support the tens of the billion file for a single training. And second is really about high availability. Because the machine learning job, actually, you always write with Python code, and it always deal with the local file system. Local file system is always have very high reliability, but in reality, in the cloud environment, the environment is not so stable. So because of this kind of gap, the problem is you will see for example, if you fail with I/O, you will fail your job. That's basically because you Python code or machine learning code really not do the retry or the fault tolerance from their side. And even you want to modify it, it's almost impossible because people always import library by library, and every library have this kind of issue. And third is really about high performance. Actually, we already mentioned before, the higher GPU utilization means you need less GPU there, and you don't need to worry about it. And after we do the redesign, actually we introduce several motivated by this kind of problem we're facing there, and we introduce this kind of change into our new storage called Dora. And first of all, previous Alluxio is similar architecture HDFS. It have the master there, and it also have the worker there. But nowadays, this kind of architecture limited by two different perspectives. First of is the metadata storage performance. It usually for the list status is 40K to 50K based on your hardware availability. But for the new Dora architecture, it easily can achieve 20K to 30K for each node. So if you have 10 nodes, it will magnitude by 10. And if you have hundreds of nodes, it will times by 100. And another one is really about fault tolerance. Actually, this new design is really designed as a catch. So for example, if you shut down one node there, actually it will not hurt your performance a lot. For example, you have 100 nodes there, shut down one node just means you only shut down one node for the data availability, but the Alluxio still will reroute you to the system and get the data back from that. And another one is really about Kubernetes environment. Nowadays, no one is not using others in the AI machine learning training without Kubernetes. Actually, with Kubernetes, it's better for you to do the multi-tenancy and better for you to serve the data. In this part, we are also provide the different interface like CSI with the views in the Kubernetes. At the same time, we also build a concept with a data set with your model, and you can serve from your Kubernetes cluster to the upper like PyTorch and the TensorFlow without understanding what is Alluxio doing there. It can easily for you, if you have the knowledge of the Kubernetes, you can do your job and you can manage all the data set from the underlayer. And second, it's about performance. Performance is previously we use the gRPC to do the data transmission. Actually, we even write one blog called how we go from the NATI to the gRPC because the easy of use of the gRPC. But nowadays we realize gRPC is even impossible for you to implement zero copy with your socket and your memory. So actually we change back to the NATI for the data transmission. And actually it's have insane performance improvement for your data serving to your machine learning and AI. And otherwise, it will be minor, but actually just think about nowadays what's the most popular way for people to do the machine learning training is for one single training, they will have one raster cluster, one storage high performance computing cluster for serving the data. But actually it's very expensive, not only hardware, but also since you have to allocate one specific hardware cost for the single team, actually you cannot reuse this kind of work from the team. Actually, at our side, we will support the multi-tenancy. We support multi-tenancy per worker. So which means even you launch one Alluxio cluster, you can still split by the needs to the model training. And after you don't need it, actually you can just destroy the cluster without worry about the data consistency there. And the last one is actually what we get from the user is really people not really calculate a lot in the AI machine learning training, because whatever you have to move the data from the cloud storage to the high performance computing cluster, then you do the manager there. But actually in our system, we still provide some token-based security for you to use for the very customized security requirement. Okay, then this part will be more technical, but I still want to mention a little bit how we really achieve this kind of high performance. First of all, previous, like if you imagine at the master and worker architecture, when you have a call, for example, at your field side, you have a call to the system, you have to get the list of the file from the master first. Then master will return the list of the block location to your system where the data it is. And at the worker side, actually, after worker set the connection between the worker and the client, and it will return the data back. Actually, it's not so efficient for the AI machine learning training. It's okay for the data analytics, but not okay for the AI, because actually just think about you have billion of file. If you provide the single master with 50K of the IOPS for the get status, it will wait for the infinite time for you to get all the data into your system. So it's the big problem for the most of the object store for the storage system in the past. So we change the way how we do that. Actually, we will decide which worker we want to get the data from the client side. Client will just directly talk with the Alluxio worker and return the data back there. If you think about RPC call, at least it's save 2 to 3 RPC call to the master, and also save the master to become the single point of the performance bottleneck for your system. So in this kind of architecture, we really can achieve very good performance. Even with a single worker, we can easily achieve 50 million of the what we call nowadays we call page store there. You can just imagine you can easily save more than 50 million of the files in a single node, and at the same time, it also provides you infinite scalability from the system. And the second is really, we mentioned before, it's the performance improvement by the NetT. And with the NetT, actually, we can really implement zero copy transformation. So, which means previous, we have to serialize the data and put into the gRPC and send out, and you have to deserialize again from the other side. Nowadays, we just, without any copy, we just put from the memory to the NIC, then translate out. Actually, it gave us 30% to 50 times of the performance improvement. And the last one is really about the we special optimize for the large language model training. Because previously, if you think about the large language model training, it always have the large file there. It can be hundreds of the megabytes or even gigabytes of file, a single file with the different format like TF record, arrow, as you can think about. The bottleneck there is actually for this kind of file, fields will initiate a lot of seek, and at the same time, it will do a lot of position read there. In the new design, actually, we make the read alignment much better than before. So actually, it's really improve the performance from the consumer side at the PyTorch and TensorFlow to the Alluxio system. So it increased about the next 9 times for the unstructured data and the 2 to 15 times for the structured data. So no matter you stored in the raw format or you stored in the packet format or the TF record format, actually you will get a benefit for this kind of optimization. I think that's all. And feel free to visit our website, and I believe Hope have a lot of the good use cases analysis there, no matter it's from the largest fintech in the world, Alipay, or it's from the different user and customer. And also feel free to join our Slack channel, and we also post our promotion in the social media. And the most important, join the GitHub. Actually, I go through the GitHub every day. So you have any issue running with Alluxio, or you have any question there, you can feel free to chat with us there.
Thank you, Shouwei. I think now we have arrived at our Q&A session, and we will do our best to answer as many questions as possible. Feel free to type your question in the chat, or you can use the Q&A to submit your questions, and I will read them out for everyone. So in the middle of your presentation, Shouwei, I got some questions from Sharath MK. The first question I have is, when we run ML training using Fuse in Kubernetes, what happens if Fuse pod crashes for some reason? Does ML training also will be impacted? Any way to have high availability of Fuse?
Yeah, I think I should know Shiraj. I have one meeting with him before. And actually, it's a very good question. It will be more technical, and I try to answer the question. The most of the time, like we saw Fuse crash, is really because because you have run a large number of the file in a Fuse pod, and actually it's called OM, and Kubernetes will kill it by default. And actually it have two different ways to solve this problem. The first way is very straightforward. You can increase your memory at the Fuse pod, and at minimal, like I remember maybe 16 gigabytes is more than enough. Maybe like in most of cases, like if for secure, maybe you can increase the 32 gigabytes of memory to ensure it will never crash. But another perspective is like you still can turn off the metadata cache at the field side. So actually, if you turn off the metadata cache, it will not cause this problem anymore. But at the same time, you also will sacrifice a lot of a little bit of performance, maybe 20% or 30% of performance from your pipeline. So it's just trade-off there. But in our new architecture, I don't think it's a problem anymore. And feel free to join the Slack and chat with our engineer there. I think they can give them much better answer than me there.
And thank you, Shouwei, and thank you for the first question. I think the second question is that how does data gets balanced within a Alluxio cluster itself? For example, if the very popular data set exists in Alluxio Worker 1 and many training needs same popular data set, and what happens to the performance? As we know in cloud, every VM has bandwidth limitation depending the VM size.
Sure. So now I know you really run Alluxio in production. So it's very good, good question. It really depends on your L pattern. Nowadays, for the 2.x line, we really recommend people to serve each data set for the each Alluxio cluster. It's meaning the constraints from the metadata side. And at the same time, as you mentioned, like the data set also have some problems there. By default, Alluxio will keep infinity copy by configuration. You can turn it to maybe 3 or 5 based on request from the data path. And it will fetch the data for each node for 1 copy. And first of all, it can solve your problem for the I called it like imbalance IO throughput from the different node. And the second problem is really about like maybe one of your storage is already fully occupied. Nowadays, we don't have a way to do that. And it's really rely on your workload to balance it by yourself. And we will not rebalance it. The reason is not really we don't want to do it because we find it's really meaningless for the caching system. For the caching system, after you fulfill your node, you always can like evict your data instead of like clean the data by yourself.
I hope it answered your question, Sharath. The next question is, when we try to use Alluxio with Azure Blob, we saw only 15% improvement. Do we need to tune some parameters?
Sorry, is also another very good question. And yeah, actually, it's for the machine learning training, like I'm not sure 15% improvement means what. It's about GPU utilization. It's about the IO throughput. What is the 15 improvement there? But if you talk about GPU utilization, I can give some hint to you. First of all, you have to distinguish what is the bottleneck there. It's for the IO throughput. Oh, okay. If it's for IO throughput, you must have to do something wrong with the parameter. And we can chat offline with the real case from your side. Yeah.
Thank you, Sharath. We will connect with you offline on Slack. Thank you. Here, Shouwei, we have a question from Q&A chat. I think you can see it. Banner has a question. Does the Alluxio solution enable the creation of data infrastructure for real-time applications that require low latency and high throughput and session caching? The Alluxio solution is a high-performance compliant object store. It can deliver large-scale ML, data lake, and other database workloads. Does it run on premises and in any cloud, public or private, and from the data center to the edge?
First of all, different people have the different definition of the real time, and some people, I mean, it's especially for in the different area, right? If you talk about Kafka or the Storm or the Flink, this kind of area, they will talk a millisecond as a real time. But in the model training wise or the inference side, we never see this kind of requirement for the millisecond of requirement. Actually, we do introduce very low latency, but this latency will be this tenth of second level to the minutes level, because previous we saw when people using the inference pipeline with the traditional object store or the HDFS, this kind of system, it really take quite a long time for them to onboarding their model to their inference cluster. But with us, actually, since we provide a much higher concurrency at our Alluxio side, actually it can reduce to from 10 minutes to 2 minutes. And I think Hope will translate that blog from the Chinese to the English.
Yes. Shouwei is talking about, we have a real world in production, a case study from the Quora, the Chinese Quora. Basically, the name is Zhihu, ZHIHU. So it's a company in China that has the same business as Quora. It's a huge community there. We are actually behind the scene of their LLM infrastructure. We will publish the case study in about 1 or 2 weeks. Stay tuned.
Yeah, and the second problem is really Alluxio solution high performance compliance object store. It can deliver data lake and advertise wrong promise. Oh, first of all, I think it's very good command. I like it. And first of all, we are not designed for the highest performance, because highest performance rarely need the very tight integration between the hardware and the software, which means you have very limited choice and also very expensive. As I mentioned before, it's impossible for you to always have the RDMA and NVMe integrated very hardly. And so actually we designed for the general hardware, like the general EC2 instance. But at the same time, most of the time we still can satisfy more than 90% or 80% of the GPU utilization as your side. I always said that actually it doesn't matter or it's running on premise and in the cloud, because the biggest problem for the people nowadays is you should run your GPU training anywhere you can get your GPU training, get your GPU. It's no matter it's on the cloud or on the premise. The reason we saw in the Azure a lot, because Azure do have a lot of GPU resource. That's the reason people really move to the Azure and they do the training there. But at the same time, we can help you to, no matter your data where it is, it can in the Azure itself, and or it's in the GCP or even in the S3, AWS S3. Actually, it doesn't matter. And if you have the GPU on premise, you can just run on premise.
Does that answer your question? And we can follow up with you on Slack. I have posted the Slack link here. Please join. And then if you have any follow-up or further questions, and we can help you answer them on Slack. So, Shouwei, seems like we don't have any further questions here. Just like one final note, join our Slack, and start our GitHub, and then follow us on Twitter or LinkedIn, and really thank you for joining and attending and participating actively in our session. And special thanks to Shouwei for addressing the questions and the great presentation. It has been very pleasant to have you all here. And thank you once again, and we hope to see you in our next event. Thank you.
Yeah.
Bye.